This formula is what we use for perpetuities, and it's not on the formula sheet. So you do have to remember that formula. But just before we get into what each of those letters mean, let's just talk about conceptually what a perpetuity actually is. Now, I could go and give you a really mathematical term, but I like to sometimes use layman's terms, as I think it's easier to explain things that way in a lot of situations. So in layman's terms, a perpetuity is a situation where you get paid out forever. You give someone a big lump sum of money and then you just get paid out forever. So let's just think of an example of a person having $500,000 saved up. Maybe they've inherited that money, maybe they've saved it. Somehow they've got $500,000 sitting in their bank account. They choose to invest the money at an interest rate of 2.5% compounding monthly. That's the situation. Now, let's just find out how much interest they would be earning every single month if they had that much money and they were given the interest rate of 2.5%. So the interest that they would earn, the way we could calculate that is we could do 500,000 times by the interest rate as a decimal divided by the compounding periods. And that turns out to be about $1,000 approximately. So this person would earn $1,000 every month if they had $500,000 in this investment situation. Now, let's just imagine, hypothetically, if every single month this person just took that money out of the account. So they took the exact amount of interest out for themselves. Well, what would happen is the 500,000 would still be sitting in the account and they could just do that every single month forever. And they're essentially getting free money. This idea is what we call a perpetuity. Now let's unpack the formula, and remember, you don't get this on the formula sheet, you do have to remember it. So D represents the payment amount, the amount that you're going to get from the perpetuity every month or every quarter or whatever your compounding period is. Now in the textbook, I don't think they call it payment amount, I think they call it something else, but I like thinking of it as just being the payment amount. It's the amount that you're going to get paid out. P is the perpetuity, which is the lump sum of money that you're going to be giving to someone so that you can get paid out on a regular basis for doing no work. And I is the interest rate per compounding period. So with this formula here, we could rearrange it depending on the context and depending on what we're trying to find. So sometimes we're just trying to find the payment amount, but sometimes we might want to find the perpetuity amount or the interest rate. Using a little bit of algebra, which I'm not going to get into in this video because being year 12, this algebra is kind of assumed knowledge at this point, but we could rearrange that formula to get any of these three formulas on the screen here. Let's go through a quick example. So it says calculate the value of the perpetuity required to earn $4,000 a month with an interest rate of 5% compounded monthly. So what we're about to find out is how much money someone would actually need in order to get paid out $4,000 a month, which would be pretty cool. You'd be getting $1,000 a week on average for not doing any work. That would be awesome. Let's find out how much money someone would need to have for that situation to be a reality. So our formula is D equals P times I. In this case, we're going to rearrange it. So we're going to move the I over to the other side and divide. So we've got P is equal to D divided by I. And then when we plug in D as 4,000 and we plug in the interest rate as 0.05 over 12, being careful to put the interest rate in brackets so that we're dividing that whole thing into 4,000. When we do that, we get 960,000. So that's close to $1 million. So hypothetically speaking, but these, I don't think these are too common in the real world anymore, but hypothetically speaking, if someone had $1 million and the bank was going to offer them a perpetuity with an interest rate of 5% compounding monthly, they could get $4,000 a month for the rest of their life for doing no work, which is actually kind of cool conceptually.